An owl can look almost directly behind itself without moving its body, and the secret hidden inside its neck is so unusual that for years, scientists struggled to understand how the bird could perform this incredible feat without suffering a catastrophic injury. Imagine sitting quietly in your backyard as darkness settles in. A shadow glides silently onto a fence post. The owl appears motionless, almost statue-like. Then, without shifting its feet or wings, its head begins to rotate. It keeps turning farther and farther until it seems impossible. Yet the bird remains perfectly calm, as if twisting its head in a way no living creature should be able to. For many people, seeing this movement for the first time feels almost supernatural. It looks as though the owl is breaking the rules of anatomy. Humans can only rotate their heads about 80 degrees to either side, before muscles, bones, and blood vessels limit further movement. Owls, however, can rotate their heads up to 270 degrees, allowing them to look far behind themselves without turning their bodies. The truly surprising part is that owls cannot actually move their eyes the way humans can. Most of us rely on eye movement constantly. Even while reading these words, your eyes dart from place to place. Owls are different. Their eyes are not shaped like the round eyeballs found in humans. Instead, they are elongated tubes that fit tightly inside large bony sockets. These tube-shaped eyes provide remarkable vision, especially in dim light, but they come with a major disadvantage. They are essentially locked in place. An owl cannot simply glance to the side. If it wants to see something in another direction, it must move its entire head. Nature solved this problem with one of the most extraordinary neck designs in the animal kingdom. At first glance, you might assume owls have unusually long necks hidden beneath their feathers. In a way, that is true. Those fluffy feathers conceal far more neck than most people realize. When scientists examined owl skeletons, they discovered that these birds possess 14 neck vertebrae. Humans have only 7. Those extra bones provide greater flexibility, but flexibility alone does not explain everything. After all, if a human somehow had twice as many neck vertebrae, turning the head too far would still be dangerous. Blood vessels would become compressed. Arteries could tear, nerves could be damaged, yet owls perform these extreme rotations countless times throughout their lives. This mystery fascinated researchers for decades. The breakthrough came when scientists began studying owl anatomy in remarkable detail. Using advanced imaging techniques, they examined the pathways of blood vessels running through the neck and skull. What they found was astonishing. In humans, the arteries supplying blood to the brain pass through openings in the neck vertebrae. These passages fit relatively snugly around the arteries. If the neck twists too far, the vessels can become stretched or pinched. Severe injuries can even interrupt blood flow to the brain. Owls have a completely different arrangement. Many of the openings surrounding their arteries are significantly larger than the blood vessels themselves. This extra space allows the arteries to move and shift as the head rotates. Instead of becoming trapped or squeezed, they have room to adapt to the changing position of the neck. But the surprises did not stop there. Scientists also discovered small reservoir-like areas near the base of an owl's head. These structures may help maintain blood supply during dramatic movements. Think of them as backup systems that ensure the brain continues receiving oxygen-rich blood even when the neck is twisted into positions that would be dangerous for most animals. Nature essentially engineered a solution that protects the owl from the very problems humans would face. The neck bones themselves are equally remarkable. The joints between vertebrae allow an unusually wide range of motion, combined with specialized muscles and ligaments. They create a neck capable of movements that seem almost impossible. This flexibility serves a critical purpose in the owl's daily life. Unlike many birds, owls are ambush predators. They spend long periods perched and waiting. Remaining still helps them avoid detection by prey. If an owl had to constantly turn its entire body to monitor its surroundings, it would reveal its presence and waste valuable energy. Instead, the bird can sit motionless while its head quietly scans the environment. A rustle in the grass, a mouse moving beneath fallen leaves, a distant sound in the darkness. The owl can track these subtle clues while keeping the rest of its body perfectly still. Its hearing makes this ability even more impressive. Many owl species have asymmetrical ears. One ear may sit slightly higher than the other. This arrangement allows the bird to detect tiny differences in the timing and intensity of sounds reaching each ear. The result is extraordinary three-dimensional hearing. An owl can pinpoint the location of prey hidden beneath snow, leaves, or vegetation using sound alone. To take advantage of this hearing system, the bird must be able to orient its head precisely. The incredible range of neck motion helps it position its ears and eyes exactly where they need to be. If you're enjoying these hidden secrets of the bird world, be sure to subscribe to Backyard Bird Mysteries for more fascinating discoveries about the remarkable creatures living all around us. The more scientists learn about owls, the more extraordinary these birds become. Their famous head-turning ability is often misunderstood. Many people believe owls can spin their heads completely around. They cannot. A full 360-degree rotation would be impossible and deadly. The actual maximum is about 270 degrees, which is still astonishingly greater than what humans can achieve. Even this limit is carefully controlled by anatomy. Specialized bone structures help guide movement while preventing dangerous over-rotation. The neck is flexible, but it is not uncontrolled. Every feature appears finely tuned through millions of years of evolution. When you watch an owl hunting at night, you are seeing the result of countless adaptations working together. Large forward-facing eyes gather available light. Sensitive hearing locates hidden prey. Silent feathers allow stealthy flight. And the famous rotating head ties everything together, giving the bird awareness of nearly everything happening around it. The effect can be eerie. Throughout history, people have viewed owls with a mixture of admiration and fear. Ancient cultures often associated them with wisdom, mystery, or the supernatural. A bird that could stare silently into the darkness and rotate its head in seemingly impossible ways naturally inspired stories and legends. Yet the real explanation is even more fascinating than myth. What appears magical is actually a masterpiece of biological engineering. Every vertebra, artery, muscle, and feather contributes to a system designed for survival. Consider the challenge from nature's perspective. Create a predator that hunts in near darkness. Give it large eyes optimized for gathering light, even though those eyes cannot move. Then ensure it can monitor nearly everything around it without revealing its position. The solution is an incredibly flexible neck supported by a network of specialized blood vessels and protective structures. The result is the owl we know today. Next time you spot one perched on a branch, take a closer look. Beneath those soft feathers lies one of the most sophisticated neck designs in the natural world. What seems like a simple head turn is actually the product of extraordinary anatomy hidden from view. The owl's ability to rotate its head 270 degrees is not just a curious trick. It is a survival tool, a hunting advantage, and one of the clearest examples of how evolution can solve complex problems in astonishing ways. And as remarkable as the owl's rotating head may be, there is another backyard bird with a hunting ability so strange that scientists once thought it should be physically impossible.